Let's have a look of this particular code and understand. Now, in this code, we are creating a data frame with the help of data.frame function, where our first value or first column is the value ranging from 1 to 8, and the second column is a factor of the vector BA, BCC, AC, BA. So basically, the first value is a series and the second one is a factor, and that is how we have created a data frame which is having two columns. Now, filling some NA values in the data frame is done by using the command where we are writing data frame 4,1 is equal to data frame 6,2 is equal to NA. So what we have done over here, we have entered some NA values at certain locations of the variable data frame. Now, printing all the levels, NA is not considered 1. So now here we see that the first command that we apply over here is we write levels df $C4. So basically df $C2. So what we are doing for the data frame df, we are taking the column C2 column, which is basically a factor. So you can see over here that when we see the output of this command, we get A, B and C. So we are getting A, B, C as an output of this command. Now, next is we are testing what happens if it is NA.fail. So fail if NA is encountered. So you can see over here that I am calling a function NA.fail, and within brackets I have passed df, which is my data frame variable, as a parameter. And I can see the output over here that error in na.fail.default df missing value in object. So basically I get, if I say na.fail, I get a suitable error message on the screen, na.fail.df default df, which means na value is encountered. In case I don't want even a single na, I am displaying that on the screen. Now we will see the third thing, where we are using exclude every row containing even one NA. So in that case, what we are doing? In that case, we are using NA.exclude and within brackets A. So I'm calling the function NA.exclude and I'm passing A in it. Now let's see what is happening. So here you can see I get calls NA.fail default. This is the error. And in the last one, na.exclude, you can see execution halted. So that is how the output is coming on the screen. And you can see over here that the functions are used by just using na.fail, where there is df, and in the na.exclude we see that there is no error, where we have seen that it has excluded and it has every row, it has excluded every row containing every NA, and then it has printed the result in the variable A. So that is how we are using the code and trying to filter out the NA values, or sometimes we exclude the NA, or sometimes we halt the screen, sometimes we display a suitable message, and sometimes we insert NA values and see the result on the screen. Now, let's come to a very different topic, which is called as extracting a subset of a data frame. Let's take one example and even understand what is the meaning of subset. Suppose there is information about a lot of students, whether they have a driving license or not. So all those who are having driving license is having true, and those who are not having driving license is having a value false. So what I will do, I will apply a filter on my data frame, and I will only project the reports, project the records on the screen where the driving license is equal to true. So that is how I'm bringing only those records which satisfy the condition whether driving license is equals to true. So that is how I can select certain rows. Likewise, I can also select certain columns from a data frame and only project few columns which are of my choice. For example, I want to see only employee name and his salary, or maybe employee name and working days for the month. So I will only project two columns, employee name and the working days in the month. So that is how I'm bringing a subset on the screen. The data frame can be huge. It can have hundreds of columns. It can have thousands of rows. But sometimes I only want few rows, few columns, and then I require some kind of extraction of data from the data frame. So students, a very powerful function, subset function, is present in R programming, and it is used to create subsets of a data frame. This can be used to drop columns from a data frame. Drop column means that I'm removing the columns from my data frame in my result. So in my result, I only take the columns which are of my interest, and that resultant data is called the subset of the data frame. How you will go about it? So the syntax, subset, which is a function within brackets, I pass two parameters. The first one is df, which means data frames, and the second one is expression, which is the condition for subsetting the data. So basically data set, comma, condition, and that is what we pass into the subset function, and we can get the subset of the data very easily on the screen. So you can see df stands for data frame that we are using, and EXPR stands for the condition for subset. For example, the driving license equals to true. So that is how I can extract a subset. Everything is incomplete if we don't understand the same in the language of coding. So this is the best example of subset function, where we are creating a subset of a data frame with the help of certain parameters. So first of all, let's understand that what is the data frame. The data frame has row 1 equals to 0 to 2, row 2 is 3 to 5, and row 3 is 6 to 8. So you can see over here that the data which is in the blue is our row 1, row 2 and row 3. So you can see the data is actually, the column is considered as row over here, where row 1 is the title and row 1 is ranging from 0 to 2. We can see row 2 is again from 3 to 5, as you can see the value 3, 4, 5, and row 3 is 6, 7, 8. So first we print the original data frame, and we see with the printf command it is coming as an output on the screen. Now, how to create a subset? Very easily. What we have done, we are creating a subset by calling the function subset, as you can see over here. Subset, within brackets I pass df, comma, select equals to row 2, which means I am selecting row 2. So now only row 2 will be projected on the screen. And then I write print modified data frame, which means I'm printing the caption modified data frame for the readability of the user. And after that, I use the print command, and within brackets, I pass the variable df1, where I have captured the row 2 from the original data frame, which is df. So you can see df was my original data frame, which you can see in the blue color, and then my second data frame, which is df1, is in red color. Here only row 2 is selected. Rest all rows are suppressed. So how nicely I can find out a subset from a data set. R script. So R script is, as we have seen in the previous lecture also, that how to create a R script. We will just have a little discussion on it, that you will do your programming by writing your programs in script files, and then you will execute those scripts at your command prompt with the help of R interpreter called R script. So mainly R scripts are the scripts, or we can say they are the programs where we are writing the entire R command sequence and saving that code in a file with the name test.r. For example, test is my file name, so I will save my file with the extension R. So what I'm doing, I'm saving my code, whatever code I have written, I'm saving that with an extension R, and that file is called as R script. It is very much like any C program that we save, or any other programming language which is used to save a file. The same way we can also write our programs and save those programs. Why we save the programs? We can execute at those programs at the command prompt later. We can reuse those programs again and again, because if we are writing our own programs with the help of our interpreter, which is called R script, I can always run a particular R file, for example, test.r. Next is adding comments and documentation. So students, first understand the concept of documentation. Why documentation is needed? First of all, whenever I'm writing a program, I need to document that properly, because today I have written that program, but tomorrow I might quit the office and some other person joins that place. So in that case, that person should understand the code easily and make some changes. Consider any software, let's say Microsoft Word or PowerPoint. It keeps on updating and a new version comes. So the code is very old, but the team keeps on changing. So that is the one reason why we add comments in the code, so that the understanding of the programmer increases, plus the new people who are joining and working on the old code can understand easily that what has been done in this program. And that is one reason why adding comments is important in the program, and why documentation is important. The comment character is hash. Everything after this character in an R script is ignored when executing the compiler. So suppose I have written a complete sentence and it is starting with hash symbol. It means that particular line is a comment line, and that line will be ignored by the R compiler. So that is just an explanation about the code, that what this code is doing next. And it is a good practice that we apply a lot of comments in our code. We can use the comment character to add small comments to our code. So we can have some more comment characters. And secondly, when we are documenting our code, we have to document the code in such a way that within the comment, we give the module number, the number of the program, which program it is above that program, and which programs are below that. And that comes under the part of documentation. So when I'm keeping my R code at a location, I need to understand that I have to accept one nomenclature first, and through the nomenclature, I have to store my data. If there are folders, I have to store that data in a folder. And if some more data comes which is categorized, then I have to create subfolders, and there I have to store the R scripts. So that is how we have to keep our data and document it with the help of comments, so that it becomes very easy to understand. Kindly refer all the codes whichever I'm using, where continuously I'm commenting my particular program, so that you can understand what that program is all about. Creating reports. Now, creating reports is a huge task, and it is very easy to create reports in R. The first step is to create a R markdown file with an extension .rmd. If you are using RStudio, you can go to File, New File, Arc Markdown to create RMD file. So students, it is very easy to create reports in R. The only thing is, if you are using RStudio, you just open File and Arc Markdown file and save your file as RMD file. You should specify whether you want an output in HTML, PDF or Word. So basically, creating report is very simple in R. You can try this on your own and you will find it very interesting and simple. The only thing is that when I'm printing the output on the screen, it can go as HTML or PDF or Word. So there you have to understand that which format you want to use to create a report. The ideal format is PDF file, because PDF reports are widely accepted everywhere and easy to understand, and we cannot override that easily. And that is one reason PDF files have become very crucial and very important when we are creating a report. So students, with this, we end this session, this lecture on the topics what we are discussing today. And I hope you are able to understand the concepts of R programming. R programming is a very simple programming which has almost the constructs of a programming languages, libraries, packages, functions, and how to use the functions, how to deal with the data, and how to understand the data. In the coming lectures, we will have some more insight on R programming with certain advanced programs. Till then, have a great day. Thank you.